So how's everybody doing out there? Well, hopefully everybody did a good job of finding our confidence intervals with means. So for 7.3, we're moving on to finding confidence intervals using proportions instead, but the idea is very similar to what we did before. So with this one, our point estimate, instead of being a mean, our point estimate is going to be a sample proportion. So if we look at number one, to find our sample proportion, we're going to take our p hat is going to be our x over our n for these. And then to find our standard deviation, we're going to have to figure out what our p hat is, what our q hat is. And again, q hat is just 1 minus p for these. And then I'll divide that all by n. So we are back to z-scores in this section. So with proportions, we're always going to be using z-scores and our normal distribution. So if we look at our formula for this, you can see that this looks pretty much exactly like what we had before, except for we had a mean instead of our sample proportion, and our standard deviation is just going to be this square root of p hat q hat all divided by n. And so with this one, since we're trying to estimate the population proportion, so notice when we put it in expanded form, we're going to get just regular old p in this case instead of mu. And then our margin of error, just like before, is going to be our z-score times our standard deviation. So that looks exactly the same. And then again, finally, to put it in its kind of more expanded form, we're looking at that. All right, so let's dive in and take a look at an example so we can see how this works here. So for example one, Nielsen Company surveyed 225 owners of Android phones and found that 160 of them plan to get another Android as their next phone. Construct a 95% confidence interval for the proportion of Android's users who plan to get another Android. All right, so notice with this one, all we're given is our n and our x. And so from there, we have to figure out all the other stuff that we need. So we know our x is going to be 160. Our n is going to be 225. So if we want to figure out our p hat, it's going to be the 160 divided by 225. So let me throw it in the calculator real quick. And so we see that we're going to get 0.71 repeating over and over and over and over again. So I'm just going to write this as 0.71. And then we need to know our q hat. So our q hat is going to be 1 minus 0.71, which is going to be 0.29. And then we do need to figure out our standard deviation at some point in time. So again, that's going to be our sigma equals our p hat. So 0.71 times our q hat, all divided by our n, which is 225. So let's go ahead and throw that in the calculator while we've got it here. So square root 0.71 times 0.29, all divided by 225. So it looks like we get a standard deviation of 0.0303. All right, and then finally, we're interested in a 95% confidence interval. So since we're dealing with a z-score, if you remember from section 7.1, this is going to be a z-score of 1.96. All right, so now we've got everything that we need in order to set up our confidence interval. So we're going to get our upper bound is going to be our p hat. So it's going to be 0.71 plus our z-score, 1.96, times our standard deviation, which I saw was 0.0303. And then our lower bound, which is going to be 0.71 minus 1.96, 0.03 0.03. So let's go ahead and plug these in the calculator real quick and see what we get. It's 0.71 plus 1.96 times 0.0303. So it looks like we end up with 0.769, or 76.9% as our upper. And then our lower, we're just going to go and change that plus to a minus. And so it looks like 0.651%, or 0.651. All right, so putting everything back together, it looks like our p-value, our population proportion, is going to live somewhere between 0.651 and 0.769, or if you like these to write these in percentages, it would be 65.1% less than p, less than 76.9%. So either one of those are correct. All right, so for B, it's asking us a little question. So assume that an advertisement claimed that 70% of Android users plan to get another Android. Does the confidence interval contradict this claim? And so the fact that 70 kind of falls somewhere right near, not exactly in the middle, but pretty close to the middle of the confidence interval we found, this definitely doesn't contradict the claim. It seems to support the claim. So our confidence interval seems to support the claim. All right, perfect. So if everybody understood that, if you didn't, let me know so I can help you out with them. All right, so practice 1, I'm going to work through this one with you real quick. So this is another one of these ones like we did in 7.1 where we're trying to work backwards to find the point estimate and the margin of error. So if you remember the way we did this from 7.1, we took our two upper and lower bounds. So we took 0.278 and added it to 0.338 and then divided by 2 to figure out what our point estimate would be. So let's do that first. 0.338 divided by 2 gives us 0.308. So our point estimate appears to be 30.8%. And then finally, if we want to find our margin of error, we just take either the upper or the lower bound and subtract it from our point estimate. So I'm going to take the upper bound. So in this case, I can see that I'm going to get 0.03. So it looks like my margin of error is about 3% for this. All right, perfect. So let's have you guys work on practice 2, practice 3, practice 4, and stop once you get to practice 4, come back to the next video, and we'll talk about how to find the sample size for a set of data. All right, good luck, everybody.